To wrap up the overview of Java threading, we're going to evaluate the different Java thread programming models so you have a good feeling of the pros and cons of them. And we've already talked about these models, but we'll just recap them. And we'll refer back in several cases here to our GCD concurrent app case study in order to kind of ground the discussion. We want to anchor the discussion in something tangible, something real, not just talk abstractly about this stuff. So we'll start out by talking about the pros with extending thread. So you can see here's GCD thread where we extend thread. It's very straightforward to do this. You just say GCD thread extends thread, boom, you're off to the races. And then you simply override the run hook method and put in your business logic. All the state, all the methods are all consolidated in one place. You can see here that we have this method called setActivity. We have an activity. Everything's connected together. It's nice and centralized. And this allows us to just deal with this thread by itself. If we want to start it, we want to stop it, we want to join it. I guess we don't really stop it, but we can interrupt it, we could join with it, and so on and so forth. There's just one place to go to deal with that. And this design is particularly useful in Android when you're dealing with something called runtime configuration changes. A runtime configuration change in Android is when you have your phone in, say, portrait mode and you move it to landscape mode. It causes the activity to be shut down and restarted with a different orientation. That's what's called a runtime configuration change. And by putting everything in one thread, it makes it very easy to do that kind of stuff. In particular, you can interrupt and restart a running thread and read and write its state, and it's all nicely consolidated in one place. It's one-stop shopping, which is great. However, as I always like to say, all is not rainbows and unicorns. There's also some cons with extending the thread. So one con, which you may be familiar with if you're a Java black belt, is that if you extend the thread superclass, that means you've lost the ability to extend anything else because there's only single inheritance of classes in Java. So you can only have one superclass per subclass. So GCD thread would be a subclass, thread would be a superclass. You can only have one of those things. So let's take a look at an alternative approach, which involves implementing Runnable. So you can get the same behavior, just a slight different structure to your code. So keep in mind that one of the pros of using the Runnable approach is that a subclass can implement multiple interfaces. So as you can see here, we have GCD Runnable that implements Runnable, implements serializable, and extends random. So you can have a whole bunch of things that you implement, but you can only extend one thing. And that enables us to extend with a different subclass than thread, which could be useful, could be not useful. Honestly, it's usually sort of 6 of one, half dozen of another. It's not that big of a deal either way. Runnables are also more flexible because you can reuse them in other contexts, whereas extending thread is narrowly anchored to only one context. And so in particular, as you can see here, the executor executes the command. We create a command up here, and now we can either start up a thread that runs that, or we could have a thread pool. So there's more flexibility here. Again, not everything's rainbows and unicorns. The downside with implementing Runnable is there are more moving parts. What does that mean? Well, now we've got to deal with threads and runnables as opposed to just dealing with a thread. So here you can see we have to make a new runnable. We have to make a new thread. Those things are loosely coupled. And this decoupling can get complicated if the program needs to access the state of a runnable, but only holds a reference to the thread object. So you have to now keep track of the runnable and the thread and work with them in concert as a pair. Not the end of the world, by the way. There's all kinds of ways to do this. It just is more work, more things to keep track of. In practice, much production software implements Runnable rather than extends thread, just because it's more flexible in many ways. Not to say that people don't extend thread, it's just more common to implement Runnable. And as I think I mentioned earlier when we were talking about this topic way back at the very beginning, Lambda expressions are now a popular way to provide computations to threads on modern Java platforms. And so as you can see here, we can make a new thread. It has a Lambda expression, which essentially constitutes a runnable. That'll cause a runtime stack to be created, and that'll cause that runnable Lambda to be the entry point into that new thread. Okay, so that's our overview of Java thread programming models.